Alright, my friends, so we're talking about absolute value inequalities, and I'm trying out a new way to do this. I'm on my iPad this time. If you guys like this more, please make sure that you give me that feedback. If you don't like this, especially remember to give me that feedback. So with absolute value inequalities, we all know that the original inequality rules apply, which means if we're dividing or multiplying by a negative, our signs flip. So we just want to remember that and put that in the back of our minds when we're doing these kinds of equations and our inequalities. So the first thing we always do is check if our absolute value is by itself. We see here that our absolute value is by itself. There's nothing before it and there's nothing after it. And we're only looking at the left-hand side of my inequality. And we know that we always ask ourselves that if it's a negative or a positive, we know this one's going to be a positive because our 5 is positive. So we're going to be going down this way on our map. So we know that our inequality is already isolated. Our absolute value is already isolated. Now we have to make our two cases since it's a positive inequality that we're working with. We have to ask ourselves, is this an and or an or case? We know it's an and case because our inequalities match what the sign needs to be for and. So when I make it's been going kind of weird with my pencil. When we make our two cases, we know that they're going to be an and case. So let's go ahead and try that out. So we're going to make our two cases, case 1 and then case 2. With case 1, we know that our inequality is going to be staying the same since we're going to use the positive 5. When we're using the positive 5, our case stays the same with our inequality. However, on this side, we know that it needs to be the negative 5. When we're working with inequalities and our case is going to be the negative case, we are switching our sign. We must always switch our sign. So case 2, x is greater than or equal to negative 5. We've made our cases, we have flipped the symbol for our negative case, just like our steps say to, and now we're going to solve each and graph. If we look at them, they are already solved. My x is already by itself. They've already been solved. How nice for us. Our case is that easy. So I can just go straight into making our number line and plotting our points. I have negative 5 and then I have 5. And are they an open or closed circle? They are closed circles. Very good. They're closed circles because I have an equal sign at the bottom. And because it's an and question, we always are going to shade in between my points. And that is the graph for my absolute value of x is less than or equal to 5. Let's go ahead and try number 2 now. Number 2, I ask you again, is it isolated? It is isolated, so we're good to go for our cases. So we're going to go ahead and open up our two cases. We must ask ourselves, is this an and or an or question since we are working with a positive number? We're working with a positive number right here, so we're going to be working with this inequality. This inequality is another and example. So let's go ahead and start making it. So we know that it's going to be an and example. When we make our cases, we have case 1. Case 1 is going to be the inside of the absolute value is less than 7 since I'm working with the positive value. So I have negative 2 plus 7. Ooh, that's funky. Negative 2 plus 7 is less than 7. So we're going to solve that soon, but I just want to make our second case before we solve that. Our second case is the same thing. We have the negative 2n plus 7. However, we are going to have to flip our sign. We're going to have to flip our sign because we're working with a negative 7 this time. So our sign gets flipped, and we are working with our negative 7 on this side. So let's go ahead and try to solve case 1. We are solving just like a regular equation. We are going to move our addition and subtraction first. We're going to subtract 7 on both sides. I have negative 2 is less than 0 because 7 minus 7 is 0. And then I'm going to divide by negative 2 on both sides so I can get my n by itself. N is greater than 0 because I divide by a negative. It is greater than 0 because I divided by a negative. Make sure that we have that, and if you need it, Go ahead and remind yourself. Make a reminder. Divided by 0. Oh, divide by a negative, sorry. Divided by a negative. So my sign has flipped. Let's try the next one. So go to case 2. Case 2, we do the same thing. We're going to subtract 7 on both sides. I have negative 2n is greater than negative 14 because negative 7 minus 7 is negative 14. Then I'm going to divide negative 2 on both sides. Dividing by a negative changes my sign again, so my case 2 got changed twice. It's going to change backwards. So I flip my sign, and I have n, because it's a form of 1, I have n is less than 7. So let's go ahead and make our graph. I'm going to make it on the side here. 0 comes before 7, and then 7 is on the right hand side. Is this an open or closed circle? They are open circles. They are open circles. And it's an and question, which means I'm going to be shading the inside. And as just a reminder, I have n is greater than 0, so I'm going to be going upwards like this. And then I have n is less than 7, so that makes sense on why I'm only shading in between 0 and 7. N can only be the values in between 0 and 7, or else my inequality would not work. Let's go ahead and try another one. So for this next one, I put my rules on the side still, but now I ask you, is my absolute value isolated? Is my absolute value isolated here? The answer is no. My absolute value is not isolated. I have a negative and 5 in front of it. Now I ask you, is there a visual operation between that negative 5 and that absolute value bar? If your answer is no, that means I have multiplication here. I have multiplication here, so I have to do the opposite of multiplication, which is divide by a negative 5 on both sides. I am dividing by a negative. Oh my goodness, all this negative work. I divided by a negative, so I'm going to change the sign of my inequality. I see a form of 1. I have negative 5 over negative 5. So I have absolute value of x plus 4 is greater than or equal to 6. Now I ask you, is my absolute value inequality a positive one or a negative one? 6 is positive, so I'm going to go down the positive route. This is looking really good. I have this. I'm going to make our two cases. We know that this is going to be an OR question because it matches my OR inequalities. So my OR question, oh, funky. There you go. So my OR question, I have x plus 4 is greater than or equal to 6. And my second case is going to be x plus 4 is the negative version of 6. That means I'm going to switch my sign. My sign is going to be the absolute value, sorry, not the absolute value. X plus 4 is less than or equal to negative 6 for my case 2. This is case 1, and this is case 2. Case 1, I'm going to subtract 4 on both sides. So I can get x by itself. X is greater than or equal to 2. For case 2, I have x, I'm going to subtract 4 on both sides. I have x is less than or equal to negative 10. So if I made my graph, I put my negative 10 because that comes first, and then 2 on the right. They are both a closed circle. And it's an OR question, which means they're probably going to go in separate directions. For negative 10, I have less than or equal to for my x. So my x is going to go in the negative direction. So let's go ahead and make that happen. And then x is greater than or equal to 2 is my second inequality for my case 1. That means I'm going in the positive direction for my x values. And that is example 3 all completed. I like this question, but I'm going to make this question for number 4 a little bit better for all of us, so we can kind of see something else happen, something new happen. I'm going to have greater than negative 2. So, is my absolute value by itself? It is not, so I have to multiply 7 on both sides so I can get rid of this division of 7. So I have the absolute value of k minus 5 is greater than negative 14. I did not multiply or divide by a negative, so my inequality sign stays the same. Now I must ask, is my question a negative or a positive? It is a negative. So I will be going towards whether my absolute value is greater than a negative or less than a negative. So we know that absolute value of anything is a positive value. We know the absolute value of anything is a positive value when I get it out. So this is asking, is a positive value greater than a negative value? Is a positive value greater than a negative value? It is. It is greater than a negative value. So we tell ourselves this is true, because a positive, and any absolute value will get a positive value, is greater than a negative value. This is true, which means that this is a infinite solution question. This is an infinite solution question. So this is saying that my graph has all of these numbers. I don't even need to put any numbers on my graph. It's going to be infinite solutions, so anything on the number line can work for infinite solutions. If you see a question that looks like this, the absolute value, let's actually move to a new page. The absolute value, so here we are with x minus 7, let's say. And let's say this is less than negative 3. I ask you to think about your... Oh, that's not what I wanted. I need to get rid of that. Oh, whatever. Not that we have to play by any rules or anything. Aha, delete. So, we ask ourselves, is it absolute value? We know an absolute value is a positive number always. Whatever this is, it'll give out a positive value. We ask ourselves, is a positive value less than a negative value? Our negative 3 is a negative value. Is a positive value ever less than a negative value? It is never. This is always going to be false. It is never going to be true, which means that I have no solutions here. No solutions. No solution. Anytime that my inequality is deemed to be false. If you have any questions or any concerns, please let me know before the test. We will always have a review beforehand. But other than that, my friends, we're done. This is it. That's how we do our inequalities with an absolute value sign. Thank you.